Strategi dan perencanaan eksperimen ya. Mungkin bahasa Inggrisnya yang paling mendekati adalah design of experiment. Design of experiments itu sendiri terdiri dari 3 komponen ya, yaitu desain dari eksperimen itu sendiri, kemudian diikuti dengan melakukan eksperimen, conduct of experiment, dan yang langkah terpenting berikutnya adalah analysis of data ya. Jadi menganalisa data yang diperoleh dari eksperimen ya. Ada 2 ya, jenis desain dari eksperimen, yaitu yang tradisional ya, yang biasa kita pakai, dan kemudian yang berikutnya adalah jika menggunakan Taguchi Metode ya. Ini sangat terkenal akhir-akhir ini ya, bagaimana memilih sampel yang efektif di dalam Taguchi Metode ya. Apapun namanya ya eksperimen kita ya, maka kita mengambil data ya. Namanya mungkin sampling ya, atau kalau dalam bidang engineering itu sering disebut specimen. Tentu specimen adalah merupakan sampel ya, sampel dari bagian besar populasi. Ini adalah gambaran ya antara sampel dan populasi. Ini adalah populasi. Data yang kita ambil ya dari populasi disebut dengan sampel. Maka per definisi populasi adalah sejumlah besar data atau pengukurannya. Kalau perlu semuanya ya. Terus yang berikutnya adalah sampel. Sampel tentu tidak semua populasi diambil datanya. Ya, hanya beberapa set dari jumlah besar populasi. Ya. Semakin banyak jumlah sampel, ya, maka semakin dia mewakili dari populasi, itu ya secara filosofi. Masing-masing memiliki karakteristik sampel, memiliki karakteristik populasi, dan juga memiliki karakteristik. Sampel yang baik adalah jika sampel kita bisa menggambarkan populasi ya. Perlu dibayangkan ya bahwa kita tidak bisa, hampir tidak bisa mendapatkan data populasi. Yang selalu bisa kita lakukan adalah mendapatkan data sampel. Maka yang perlu menjadi perhatian dari peneliti ya, dalam perancangan dan strategi desain adalah bahwa sampel kita nanti bisa mewakili populasi. Atau bagaimana dari sampel yang kita peroleh kita bisa meneropong behavior atau perilaku dari populasi. Begitu ya. Dikenal ya random sampling atau random sample random jika setiap sampel ya memiliki kesempatan untuk setiap bagian dari sampel, setiap anggota populasi memiliki kesempatan yang sama untuk menjadi sampel, yaitu namanya random sample. Atau bahasa Inggrisnya ini, if each item in the population, ya setiap populasi, has an equal opportunity of being selected, ya. Artinya diseleksi menjadi sampel. Itu disebut random sample. Oke ya, salah satu karakteristik dari sampel yang diharapkan mewakili populasi yang paling terkenal dan mudah dan merupakan karakteristik awal adalah rata-rata atau mean ya. Maka populasi memiliki rata-ratanya ya, disimbolkan dengan mu ya, dan ada lagi varians simbolnya sigma kuadrat dan standar deviasi atau sigma. Sampel juga memiliki mean, simbolnya adalah X, kemudian ada barnya. Juga dia memiliki varians, ya ini sama S, cuma yang ini sigma dalam huruf Yunani ya, dan dia juga memiliki standar deviation ya. Ini seharusnya berkorelasi antara sampel dengan populasi, baik mean-nya, juga variannya, juga standar deviasinya ya. Kalau menghitung mean mudah kan, tentu sudah dipahami ya, nilainya dibagi jumlah sampelnya ya, untuk sampel ya. Kalau untuk populasi ya total nilainya yang dievaluasi, misalnya tinggi ya, atau kekuatan tarik dan seterusnya gitu ya. Ya, yang di total kemudian dibagi dengan jumlah sampel kalau dalam sampel. Kalau populasi dibagi dengan jumlah populasi. Atau secara rumus mean baik untuk sampel maupun untuk populasi digambarkan pada rumus yang warna merah itu. Untuk sama saja ini rumusnya ya sebenarnya. Untuk sampel mean atau rata-rata ya jumlahnya dibagi dengan sampelnya ya, jumlah dari nilai ya. Ini dari I sampai N karena jumlah sampelnya N kecil ya. Kemudian untuk nilai rata-rata dari populasi sama prinsipnya, jumlahnya dibagi dengan jumlah populasi ya, tentu saja sampai N besar ya. Mungkin perlu diikuti ya video berikut ya, yang akan menggambarkan tentang bagaimana populasi dan sampel ya diambil mean-nya atau rata-ratanya.
In this video, we're going to talk about how to calculate the sample mean and also the population mean. But first, we need to know what the difference is between the sample and the population. What would you say? What's the difference between the two? Let's draw a circle. And let's say this circle represents the population in city XYZ. So let's say this city has 100,000 people living in it. That's going to be the population, represented by capital N. Now let's say that we want to measure the average weight of all citizens in the city. What we need to do is take a sample. It's not going to be practical to measure the weight of all 100,000 people because that's going to be a lot of work. But we can estimate the average weight of everyone living in the city by taking a small sample, let's say 100. And so the sample size, represented by lowercase n, as opposed to capital N, is 100. And so that's the difference. A sample is what it is. It's a sample of the population, a small portion of it. Now, how do we go about calculating the sample mean? The sample mean, represented by x bar, is basically the sum of all the data values divided by n, the number of individuals in a sample. The population mean, represented by the Greek letter mu, is also the sum divided by n, where n is the number of people in the entire city. This is the entire population. Ideally, we want the sample mean to be as close as possible to the population mean. And as we increase the sample size n, the sample mean will approach the population mean. So let's say if we increase the sample size from 100 to 1,000, we can get a better estimate of the population mean if we do that. But it's going to be 10 times more work to measure the weight of 1,000 people as opposed to 100. So there's a trade-off. If you want to get a more accurate answer, you need to do more work. Now there's something else that you need to know, and it's this. The sample mean is referred to as a statistic. Now I'm sure you heard the word statistic. Like median, mode, these are statistics. They're basically measures of a sample. Now, the population mean is not considered a statistic, but there's a different term that applies to it. The population mean is referred to as a parameter. Now, you might not be used to hearing that one, but that's what it's referred to. It's a type of parameter. Now, let's go over the formulas for a sample mean. The formula for the sample mean can also be represented this way, using sigma notation. So it's the sum of the data values, starting from the first data value and into the last one in the sample, divided by the number of data items in the sample. So this is equal to x1 plus x2 plus x3, and then this continues all the way to the last item in the sample, divided by n. Now, for the population mean, the formula is very similar. The only difference is that we're not going to be using lowercase n, but we're going to be using capital N, which represents the size of the population. Lowercase n represents the size of the sample. So let's write that. Sample size, and this is the population size. Now the rest of the formula will be very similar to what we have above. It's going to be x1 plus x2 plus x3 all the way to xn, but we're going to use capital N, divided by capital N. And so now you know the formulas that correspond to the sample mean and the population mean. They're very similar. So that's basically it for this video. Thanks for watching. In this video, we're going to talk about how to calculate the mean of a group frequency table. So what we have here is the grades of students. And you can see the grade intervals of 40 to 49, 50 to 59, and so forth. 60 to 69 will be a D, 70 to 79 is a C, this is a B, that's an A. Anything less than a 60 it would be an F in most schools. The second column contains the frequency. So this tells us the number of students who scored in this range. For instance, there are 6 students who got a D on the exam, 8 students who had a score between 80 and 89. So with this data, how can we calculate the average test score of the students in this class? Now it's important to understand that we cannot compute an exact mean for the grades in this class. And the reason why that's the case is because we just don't know the individual data values in the dataset. So therefore, we can estimate the mean. Now we know that the mean is basically the sum of all the data values divided by the number of data items in the set. But for a group frequency table, the mean is going to be something similar, but that equation will be modified a bit. It's going to be the sum of the product of the frequency values times the midpoint, because we can't really use an individual score here since we have an interval. So the best ideal individual score would be the midpoint of each grade interval. So it's going to be the sum of the frequency times the midpoint divided by the sum of the frequency values. And so that's the formula that we need to use in order to calculate the mean. So let's take this one step at a time. Let's calculate the midpoint values first. The midpoint is going to be the sum of the lower boundary of the interval plus the upper boundary of the interval divided by 2. So in the grade interval of 40 to 49, the lower boundary will be 40, the upper boundary is 49 divided by 2. So we get 89 divided by 2, which is 44.5. So that's the midpoint for this interval. Now let's do the same for the next one. So the second midpoint is going to be 50 plus 59 divided by 2. And so that's 109 divided by 2, which is 54.5. At this point, we can see a pattern. The next one is going to be 64.5, and then 74.5, and then 84.5. The last one is different. So it's 90 plus 100, which is 190, divided by 2. This is going to be 95. Now our next step is to take the sum of the frequency column. So this will give us this particular value, which will help us to calculate the mean. So it's going to be 3 plus 5 plus 6 plus 9 plus 8 plus 7. So this tells us how many students are in the class. And so there's a total of 38 students in this class. Now the next thing we need to calculate is the sum of the frequency times the midpoint values. So what we're going to do is multiply these two. Now it might be easier to basically make an extra column and then sum up those values. Okay, that line is not straight. So let's call this F times M. So what we're going to do is multiply the frequency by the midpoint. So 3 times 44.5, and that's going to be 133.5. And then multiply these two values. So that's 5 times 54.5, which is 272.5. And then 6 times 64.5. So that's going to be 387. And then 9 times 74.5, which is 670.5. And then 8 times 84.5, that's 676. And finally, 7 times 95 is 665. Now, let's take the sum of this column. So go ahead and add those numbers using a calculator. So the total that I have is 2,804.5. So now we can calculate the mean. The mean is going to be the sum of the FM values divided by the sum of the frequency values. So this right here, basically all of this, correlates to this number. So that's 2,804.5, and then divided by the sum of the frequency values, which we have here, and that's 38. Now, before we divide it, where do you think the mean is going to be? In which interval? Will it be in this interval, this one, which one? Notice that the highest frequency occurs here. So chances are the mean is going to be between 70 and 79 because most students scored in that range. So if we take 2804.5 divided by 38, this gives us a mean value of 73.8. And that makes sense since most students, they had a C on the test. Now, here is another question for you. In which interval can the median and the mode be located in? What would you say? Now, the mode occurs where the frequency is the highest. And the frequency is the highest in this interval. So the mode exists between 70 and 79. Now, what about the median? In order to figure that out, we need another column. So we're going to call this cumulative frequency. We're going to start with this number 3, and then we're going to add 5 and 3 together, which will give us 8. Then we're going to take this number, add 6 to it. That's going to be 14. And then we're going to add 9 to 14, which gives us 23. And then 23 plus 8 is 31. And then 31 plus 7 is 38. So we get this number because there are 38 students. And half of 38 is 19. So the middle number is basically the median. 19 is somewhere between 14 and 23. So after 14, we're going to be done with this interval. 23 is in this interval between 70 and 79. That interval starts with the number 15 and it ends in 23. And so 20 is in that interval. So the median is somewhere between 70 and 79 as well. Now let's work on another example for the sake of practice. So here we have the weights of different students in a class. And what I want you to do is I want you to use this group data to calculate the mean and determine which interval contains the median and the mode. So go ahead and work on this example. So let's begin by calculating the cumulative frequency. So this is going to be 6. 6 plus 8 is 14. And then 14 plus 12 is 26. 26 plus 7 is 33. And 33 plus 3 is 36. And if we basically take the sum of the frequency values, that should give us 36 as well, which we can put down here. Now let's determine the midpoint values. So it's going to be the upper boundary plus the lower boundary divided by 2, or vice versa. So the upper boundary is 139. The lower boundary is 120 divided by 2. So that's 259 divided by 2. So the midpoint for the first interval is 129.5. Now let's do the same for the second interval. So let's add 140 and 159 and then divide by 2. And so this is going to be 149.5. So we can see that the midpoint is increasing by 20. So the next one's going to be 169.5 and 189.5. Now the midpoint between 200 and 220 is 210. If you add these two, you're going to get 420. 420 divided by 2 is 210. Now let's take the frequency and multiply by the midpoint. So 6 times 129.5, that's 777. If we multiply 8 by 149.5, that's 1196. And then 12 times 169.5, this is going to be 2034. And then 7 times 189.5, that's 1326.5. And then 3 times 210 is 630. So now, let's take the sum of this column. So the sum is going to be, let's use a different color, 5,963.5. So at this point, we can calculate the mean. So it's the sum of the frequency times the midpoint values divided by the sum of the frequency values. So we have this already. That's 5,963.5. And the sum of the frequency values is 36. Now, before we calculate the mean, which interval do you think the mean is going to be? Now, most of the numbers are between 160 and 179. And the left side of the data is heavier than the right side of the data. So it's either going to be in this interval or in this interval, one of those two. So if we take 5,963.5 divided by 36, that's going to give us 165.7 approximately. So that's the mean, which turns out to be in this interval. But notice that it's closer to 160 than it is to 179. And this is due to the fact that the left side of the data is heavier than the right side of the data. Now, which interval contains the median and the mode? So the mode is basically the interval with the highest frequency, which is this one again, 160 to 179. Now the median, half of 36 is 18. Keep in mind, 36 is the number of students that we're measuring the weight of. So half of that is 18. In which interval is the 18th student located in? Now, this interval is for the first 6 students. So if we were to write a range, it would be from 0 to 6, or technically from 1 to 6. Now, this range, or that interval, covers a range of 7 to 14. You start with the next number and you stop here. Now, the interval from 160 to 179, it starts from 15 and it ends in 26. So 18 is in this interval, which means that the median is also located in this interval as well.
Demikianlah ya teori tentang dan contoh ya tepatnya bagaimana menghitung rata-rata dari data sampel yang dikelompokkan ya. Ini adalah awalnya yang berbicara tentang nilai, kemudian ini frekuensinya, maka kita wakili data itu dengan nilai tengahnya, kemudian dikalikan dengan frekuensinya, itu adalah jumlah dari datanya, dan nanti dibagi dengan jumlah sampelnya ya. Begitu kira-kira ya. Tidak tetap ada pada prinsip bahwa data rata-rata adalah jumlah dari nilai yang diukur dibagi dengan jumlah sampelnya ya. Ini adalah ketika dilengkapi tabelnya ya, yaitu kita ambil midpoint untuk mewakili kelompoknya, kemudian kita kalikan dengan frekuensi semuanya. Ya, ini kumulatif frekuensi ya, berarti ini 3 ditambah 5, 8, 8 tambah 6, 14, begitu seterusnya ya. Kemudian tentu kita bisa mengalihkan ini ya, menjumlahkan frekuensi dikali midpointnya ya, terus kemudian kita bagi dengan jumlah mahasiswanya ya, dalam hal ini jumlah populasinya, maka kita akan mendapatkan rata-rata dari data yang dikelompokkan ya. Selain rata-rata, kita perlu mode atau modus ya, modusnya ya yang paling sering muncul di sini. Kemudian yang kedua adalah median ya, mediannya adalah data ke-19 tentu, dia juga terletak di sini ya, karena ini 1 sampai 3, yang ini 9 sampai 14, yang kelas yang ini adalah 15 sampai 23, sehingga data yang ke-19 terletak pada grup antara 70 sampai 79. Kita telah mengikuti ya 2 video yang alamat aslinya ini bisa dimainkan lewat linknya YouTube ya. Dari 2 video tadi kita mempelajari bahwa untuk populasi kita bisa mendapatkan harga rata-ratanya yang disimbolkan dengan X bar, dan untuk populasi kita juga bisa mendapatkan harga rata-ratanya ya yang disimbolkan dengan mu. Rumusnya seperti di sini ya. Dan tentu ada hubungannya ya antara sampel dan populasi. Diharapkan ya min yang sama dari sampel akan menggambarkan min dari populasi atau rata-rata dari populasi ya. Tetapi sayangnya tidak seperti itu ya. Nanti kita akan beri contoh ya. Selain min ya, atau rata-rata, ada ukuran lain ya dari sampel ya dan populasi ya, yaitu varians dan standar deviasi ya. Mungkin saya akan memberikan gambaran atau contoh ya. Seorang janjian ya, dosen janjian dengan mahasiswa untuk ketemu jam 8 ya. Mahasiswanya datang jam 7:30, mahasiswa A jam 8 jam 8:30 ya. Kemudian mahasiswa B ya datang jam 8 kurang 5 menit, jam 8 dan jam 8 lebih 5 menit. Tentu ini rata-ratanya ya sama-sama jam 8 ya kan. Tiganya mahasiswa A dan mahasiswa B. Tetapi saya sebagai seorang dosen besok kalau janjian lagi dengan mahasiswa, saya lebih percaya dengan mahasiswa B untuk datang pada jam yang disepakati ya, dibanding mahasiswa yang A, meskipun semua rata-ratanya 8 ini. Tetapi ada sesuatu yang membedakan, yaitu perbedaannya dengan rata-ratanya ya, datanya. Yang paling gampang adalah ring. Nah, ini jam 8:30 dikurangi 7:30 berarti ringnya 1 jam. Kalau ini ringnya yang terbesar dikurangi yang terkecil adalah 10 menit, ini yang paling gampang ya. Tetapi hanya dengan ring ya, ring saja, maka akan menyesatkan ya, memberi gambaran yang menyesatkan. Contohnya adalah data yang terdistribusi merata, ada 1, 1, 1, 1 di masing-masing nilai, 30, 40 dan sebagainya. Nah, ini ringnya 120. Sementara data ini 9 data terletak di sini, ada 2 data di situ dan ada data yang outlier ya, seperti ini. Tentu gambaran ring saja akan menyesatkan kepada kita ya yang membaca sampelnya. Oleh karena itu ada ukuran, yaitu simpangan terhadap mean itu adalah varian dan standar deviasi ya, yang akan kita bahas berikut ini ya. Ada baiknya ya kita ikuti video-video tentang standar deviasi. Banyak sekali ya. Kita bisa lihat di YouTube. Dan ini adalah contoh 6 buah video yang bisa diikuti di YouTube ya, yang saya rasa akan dapat memberikan gambaran yang cukup bagus kepada mahasiswa pengertian tentang varian dan standar deviasi.
In this video, we're going to learn about measures of variability, another form of descriptive statistics that people often want to know in addition to measures of central tendency. But before we get to any of the nitty-gritty details, I want to kind of motivate why we need measures of variability with two examples. So here's two different data sets, one on the top and one on the bottom. I'll just go ahead and tell you that the mean for both data sets is 87. Now, if I were to just tell you the mean of these data, I would be misleading you a little bit because in reality the situation in each data set is quite different. If I were to plot it out, for example, you would see this difference clearly. In the top data set, all the scores are very clustered together. Everything is close, but in the bottom data set, scores are very spread out. So again, I need some way to quantify these differences, and a measure of central tendency like the mean simply can't capture that alone. Here's another example. Let's say you're working for a pharmaceutical company, something like that, and you need to decide between two different medications for depression. We'll call them medication A and medication B. So let's say you did a study where you measured how much improvement happened when people took one over the other, and this is what you got. So let's say over here that higher scores mean, more improvement, and lower scores mean little to no improvement. Well, let's kind of compare. The means in this case are the same. In both cases, people improved by about 10-ish points or so, but the variability is very different. On the left, some people benefited very greatly, whereas others really didn't benefit at all. But on the right, everyone benefits a good amount. In this case, I would personally pick medication B because it's more consistent. And so this is an example of why knowing the variability might help us to, make some real-life decisions. So, in general, in statistics, measures of variability are ways to describe these differences statistically. They describe how scores in a given dataset differ from one another, and they capture things like how spread out or how clustered together the points are, things we've been looking at already. So there are three that we're going to talk about. We have the range, standard deviation, and variance. Let's start with the range. The range is nice because it's a really simple measure of variability, of dispersion, of how spread out points are. It can often be calculated in 5 or 10 seconds. Here's the formula. So we have the range, R. Don't get confused later on when we learn about correlations, which are often also described by R. We'll use some different subscripts to make that difference clear when the time comes. But for now, range is R. And then we have R equals H minus L. H means the highest score in the dataset. L means the lowest score in the dataset. So you can see that this is a very simple calculation. And if we go back to the example we were working with a minute ago, we can calculate the range very quickly. So for the first data set, we have 95 minus 80, so the range is 15. And in the second data set, we have 150 minus 25, giving us a much larger range of 125. So in this case, I would do well to kind of report both to you. I'll tell you the mean and this measure of variability because that gives you a more full picture of what's going on. So a mean of 87 and a range of 15 describes a very different situation compared to a mean of 87 and a range of 125. So again, it's a great idea for me to report both, and this is what's often done. A big limitation of the range, though, is that by using it, even though it's simple and it's pretty effective, you might miss a little bit of the data, a little bit of the information in your data set. And let me show you an example to illustrate. Here's a data set here. Although these bars are quite high, there's really just one sort of value in each bar. So we have one person who scored a 30, one person who scored a 40, and so on. Now the range here is 120. It's 150 minus 30. But let's look at a second data set. In this case, the range is still 120 because our highest and lowest values are the same, but everybody's kind of over here, and there's just a couple outliers beyond that. So again, if I were to just tell you the range, I might be misleading you a little bit because you're not sure if it looks like this on the left or if the data looks like this on the right. And this is where standard deviation and variance come into play. Standard deviation, just like the name suggests, describes the standard or typical amount that scores deviate from the mean, hence standard deviation. Now we'll get into exactly what this looks like once we learn to calculate standard deviation, but I just want to show you some symbols for now. So like with means, we have different symbols to describe population standard deviation versus sample standard deviation. Population standard deviation is described by sigma. It's this sort of O with a Elvis hair, I like to think of it as, not to be confused with this sigma, which is a capital S. Unfortunately, they're named the same thing, which means take the sum of. We learned about that previously. This is sigma with a little s. So, for a sample, standard deviation is simply described by S. So I want to take a step back and talk about why standard deviations are really useful. Whenever you have a normal curve, a normally distributed set of data, which is very common in the world, things like height, weight, and so on are all normally distributed, standard deviations have this really interesting property of telling you a lot of information about what's common and what's uncommon. So if we have 0, this is right at the mean of whatever we're talking about, right? This is the mean. 0 standard deviations away from the mean is right here. You're right at the mean. We can look at one standard deviation above the mean and one standard deviation below, and we automatically know, just because of how standard deviations work, that 68% of people will fall within this range. We can go beyond that. We know that between 2 standard deviations in either direction of the mean, 95% of people will be contained. And 3, you're getting really extreme, really far out, really rare, 99.7% of the data will be contained within 3 standard deviations in either direction from the mean. To illustrate this a little bit more, let's talk some specifics. So let's say I'm looking at IQ scores. We know a lot about IQ scores. We know, for example, the population mean of IQ is 100, and we know that the population standard deviation, sigma, is 15. So let's go ahead and draw that same sort of normal curve. We know that intelligence is normally distributed, and let's kind of take a look at what information we have just by knowing standard deviation. So average IQ is right here at 100. One standard deviation above the mean would be 115. 2 standard deviations above the mean would be 130, and 3 standard deviations would be 145. And we could do the same in the opposite direction. 1 standard deviation below the mean of intelligence is 85, 2 standard deviations below is 70, and 3 standard deviations below the mean of intelligence is 55. So again, I automatically know 68% of people will fall between an IQ of 85 and 115. I also know that 95% of people will fall between an IQ of 70 and 130, and finally that 99.7 or so will fall between an IQ of 55 and 145. So this is great to know, because if you tell me you have an IQ of 146, I'm really impressed. This is rare. This is very extreme. But if you tell me you have an IQ of, say, 106, something like that, that's fine. Good for you, not very impressed, right? So knowing standard deviations helps you to kind of get this extra information about a data set. So finally, we have variance. Variance is very simple. It's just the square of standard deviation. So it's the average squared deviation from the mean. Unfortunately for variance, it doesn't get its own symbols. We just take the symbols we already have for standard deviation and we put a squared, because it's just squared standard deviation. So here for a population, we would call the variance in a population sigma squared. And for a sample, we would call the sample variance S squared. So in the next video, we'll learn how to calculate some of these things, but I want to at least highlight some of the formulas you're going to see. So we have 4 different formulas, because we have standard deviation and variance, and we have the population versions and the statistic for sample versions. So for standard deviation in the population, this is our formula. Notice we have sigma on the left, and we have all this mess, which I'll get into next time. One thing I'll mention is that for all of these formulas, the numerator is called the sums of squares, SS. And we're going to learn about what the sums of squares really means in the next video. But for now, just keep that in mind. So for our sample statistic, we have this. You're going to see an S on the left here, and it's going to have some similarities, but you're going to notice a difference or two that we'll talk about in the next video. For variance, we have sigma squared, and for sample statistic version of variance, we have S squared.
Begitulah ya video pertama ya, yang ini linknya oleh Profesor Daniel Sturridge ya dari University of Denver, Colorado ya. Tadi di video itu dijelaskan alasan kenapa perlu ukuran variasi terhadap rata-rata ya. Dan tentu yang paling mudah yaitu yang ring ya, yaitu yang terbesar dikurangi yang terkecil gitu aja. Kemudian ukuran yang paling mendekati ya, yang bisa dibandingkan antara sampel dan populasi ya tentu saja standar deviasi ya. Meskipun nanti ada ya yang lebih sophisticated lagi yaitu coefficient of variation ya, nanti ada bagian nanti kita akan membicarakannya. Kita akan mengikuti video yang kedua ya. Ini oleh Julio Gonzalez yang punya punya channel namanya Organic Chemistry Tutor gitu ya. Kalau di luar negeri link-link ya atau web yang mengandung pengetahuan tuh banyak yang akses ya, tidak seperti di Indonesia yang akses hanya link-link kehidupan sehari-hari, kemudian link yang membicarakan makanan gitu yang tentang ilmu pengetahuan kurang banyak yang akses seperti halnya di luar negeri ya. Mungkin perlu kita budayakan untuk melihat link yang mengandung ilmu pengetahuan ya. Nanti pada video oleh Julio Gonzalez yang punya Organic Chemistry Tutor itu linknya ya, akan ditunjukkan bagaimana cara menghitung, jadi ditunjukkan contoh praktis cara menghitung standar deviasi salah satunya.
In this video, we're going to calculate the standard deviation of a set of numbers. Now, there's two formulas you need to be aware of. The first one is the population standard deviation. Now, this formula is represented by the letter sigma. That's the standard deviation. It's equal to the sum of all the differences between every point in the data set and the population mean. The population mean is mu, which is this symbol here. And then you need to square it, divided by n, which is all of the numbers in the set. And then you got to take the square root of the whole result. So that's the population standard deviation. The next formula is the sample standard deviation. So let's say if you have just a sample of a population, not the entire population. If you just have a sample data out of the entire data, then you want to use this formula. S, which is the standard deviation, is equal to sigma, the sum of all of the differences between every point and the mean. That's the sample mean. In the other equation, we had the population mean represented by mu, but this is the sample mean, which is basically the average of all the data points in the set. And then you have to square it, but it's going to be divided by n minus 1 as opposed to n. And so that's how you calculate the standard deviation of a sample. Now, let's work on an example. Let's say if we have two set of numbers, 4, 5, and 6, and also 3, 5, and 7. Which one has a greater standard deviation? Let's use the population standard deviation formula. But if we had to guess, which set of numbers has the greater standard deviation? Is it the one on the left or the one on the right? What would you say? We need to understand the basic idea of standard deviation. You need to know what it measures. Standard deviation tells you how far apart the numbers are related to each other. So the more spread out they are, the greater the standard deviation. 4, 5, and 6 are closer to each other than 3, 5, and 7. And you could tell if you plot them on a number line. Let's put 5 in the middle. So 4, 5, and 6, here they are on a number line. Now in contrast, let's put the same numbers on this number line. We're going to have 3, 5, and 7. So if you look at the red points, the points in red are further apart. The points in blue, they're very close together. So therefore, 4, 5, and 6 has a lower standard deviation than 3, 5, and 7. So sigma is low, and here the sigma value is high. Now go ahead and calculate the population standard deviation for this set of numbers, 3, 5, and 7. So what's the first thing that we should do? The first thing that we should do is calculate the mean. To find the mean, it's going to be the sum of all the numbers divided by 3. Now because the three numbers are evenly spaced apart, the mean is going to be the middle number, 5. 3 plus 5 is 8. 8 plus 7 is 15. 15 divided by 3 is 5. So that's the mean. Now what should we do next, now that we have the mean? Now think of the formula. It's going to be sigma of every point minus the mean squared divided by n, and then all of this is within the square root. So here's how to use the equation. First, we're going to use the first point, 3, and subtract it by the mean, and then square it. Next, we're going to take the second point, 5, subtract it from the mean and square it. And then it's going to be 7 minus 5 squared. So each of these 3 points, you're going to plug into x sub I. And then you're going to square the differences between each of those values. And the sigma represents sum. So you're going to add every difference that you get. Or you're going to add the square of every difference that you get. And now let's divide it by n. So n is the number of numbers that we have in this set. There are 3 numbers inside. So n is 3. And then we're going to take the square root of the entire thing. 3 minus 5 is negative 2. Negative 2 squared is 4. 5 minus 5 is 0. 7 minus 5 is 2. 2 squared is 4. 4 plus 4 is 8. So we have the square root of 8 divided by 3. And at this point, we're going to use a calculator. 8 divided by 3 is about 2.67. And if you take the square root of that, you're going to get 1.63. So that's the standard deviation for 3, 5, and 7. Now let's calculate the standard deviation for the other set of numbers, 4, 5, and 6. So why don't you go ahead and pause the video and try this example. Calculate the standard deviation using the same formula. So let's go ahead and begin. Let's calculate the population mean. It's going to be 4 plus 5 plus 6 divided by the number of numbers that we have, which is 3. 4 plus 6 is 10. 10 plus 5 is 15. And we know that 15 divided by 3 is 5. So once again, anytime the numbers are evenly spread apart, the mean is going to be the middle number. So now, we can calculate the standard deviation. So sigma is going to equal the square root, but before we do that, let's calculate the differences. So the first difference that we have, the first number is going to be 4, and we're going to subtract it from the mean, and then square it. The next number is 5, subtract it from the mean, and then square it. And then after that, the last number is 6. So it's going to be 6 minus 5 squared. Now it's divided by n, and let's not forget to take the square root of the entire thing. 4 minus 5 is negative 1. Negative 1 squared is simply 1. 5 minus 5 is 0. 6 minus 5 is 1. And it's all divided by 3. 1 plus 1 is 2. So we have the square root of 2 divided by 3. Now, 2 divided by 3 as a decimal is about 0.67. And the square root of 0.67 is 0.816. So as you can see, the standard deviation is less because these numbers are closer to each other. They're not far apart from the mean. In the other example, 3, 5, and 7, they're further apart from the mean, which is 5. 3 is 2 units away from 5. 4 is only 1 unit away from 5. And that's why the standard deviation is so much less. Now let's go back to the first example. We said that the population standard deviation is approximately 1.63. So given this information, how can you calculate the variance? V-A-R-I-A-N-C-E. How can we find the variance? The variance is simply the square of the standard deviation. So 1.63 squared is equal to, now keep in mind this is a rounded answer. I don't remember what the exact answer was, but once you square it, it's about 2.66. So that's how you can calculate the variance. The formula for variance is basically the sum of all the square differences between every point and the population mean divided by n. It's basically the same formula without the square root symbol. Well, that's it for this video. So now you know how to calculate the population standard deviation and also the sample standard deviation. Even though we did just one of them, the process is the same of finding the other one. The only difference is you have n minus 1 instead of n. You also know how to calculate the variance as well. So that concludes this video. By the way, if you want to find more of my videos, you can check out my channel or visit my website, video-tutor.net, and you can find playlists on algebra, trig, pre-calculus, calculus, chemistry, and physics. So those are the subjects that I currently offer right now, and if you're interested, just feel free to check that out. So thanks again for watching.
Today is about standard deviation. After this video, you will know what standard deviation is, how you can calculate it, and why there are two different formulas, and finally, what is the difference to the variance. At the end of this video, I have a tip for you. So let's get started. So what is the standard deviation? The standard deviation is a measure of how much your data scatters around the mean. So the standard deviation has something to do with the scatter of your data. For example, how different the answers of your respondents are. Here's an example. Let's say you measure the height of a small group of people. The standard deviation tells us how much your data scatters around the mean. So we first need to calculate the mean. You can get a mean simply by summing the heights of all individuals and dividing it by the number of individuals. Let's say we get a mean value of 155 centimeters. Now we want to know how much each person deviates from the mean. So we look at the first person who deviates 18 centimeters from the mean value. The second person deviates 8 centimeters from the mean value, and so on. Finally, person number 6 deviates 6 centimeters from the mean value. So simply said, people that are very small or very tall deviate more from the mean value. Now, of course, you're not interested in the deviation of each individual person from the mean value, but you want to know how much the persons deviate from the mean value on average. So how much do these persons on average deviate from the mean value? This is what the standard deviation tells us. In our example, the average deviation from the mean value is 12.06 centimeters. And now, of course, the next question is, how can we calculate the standard deviation? You can calculate the standard deviation with the following formula. Sigma is the standard deviation, n is the number of persons, xi is the size of one single person, and x dash is the mean value of all people. So the standard deviation is the root of the sum of squared deviations divided by the number of values. For our example, this means that we calculate the size of the first person minus the mean and square that, then the size of the second person minus the mean and then square that, and so on until we arrive at the last person. Then we divide this number by the number of people, so 6, and take the root of it. The result is then 12.06 centimeters. So each individual person has some deviation from the mean, but on average, the people deviate 12.06 centimeters from the mean, which is now our standard deviation. Now you might notice one thing. I always talk about the average deviation from the mean. But for the average deviation, I would actually just add up all deviations and divide it by the number of participants, just like you calculate a mean value, right? You're absolutely right, but there are different mean values. In the case of the standard deviation, it's not the arithmetic mean which is used, but the quadratic mean. If the arithmetic mean would be used, the result would be 0 every time. So far so good, but now there's one more thing to consider. There are two slightly different formulas for the standard deviation. In the first formula, there is a deviation by n, and in the other one, there is a deviation by n minus 1. But why that? Why are there two different formulas? Usually you want to know the standard deviation of the whole population. For example, you want to know the standard deviation of height of all American professional soccer players. Now, if you had the height of all American soccer players, you would take this equation with 1 divided by n. However, it is usually not possible to investigate the entire population, so you take a sample. Then you use this sample to estimate the standard deviation of the population. In that case, you use this formula. Therefore, whenever you have data of the whole population and you want to calculate the standard deviation for just this data, you use 1 divided by n. Therefore, whenever you have data of the whole population and you want to calculate the standard deviation for just this data, you use 1 divided by n. If you only have one sample and you want to estimate the standard deviation, you use n minus 1. So to keep it simple, if your survey doesn't cover the whole population, you always use the formula on the right side. Likewise, if you have conducted a clinical study, for example, then you also use the formula on the right side to infer the population. Let's look at the next question now. What is the difference between the standard deviation and the variance? As you now know, the standard deviation is the average distance from the mean. The variance now is the squared average distance from the mean. So we have one and the same formula. The only difference is that in order to calculate the standard deviation, we take the root. In order to calculate the variance, we don't do that. To put it the other way around, the variance is the squared standard deviation and the standard deviation is the root of the variance. However, this squaring results in a figure which is quite difficult to interpret, since the unit of the calculated variance does not correspond to the original data. For this reason, it is advisable to always use the standard deviation to describe a sample, as this makes interpretation a lot easier for you. The standard deviation is always in the same unit as the original data. In our example, this would be centimeters. And finally, as promised, I have a tip for you. If you want to calculate the standard deviation, you can easily do it online with DataTab. Just visit datatab.net, copy your data into the table, select the variable you want to calculate, and afterwards you will get the standard deviation in a very easy way. I hope you enjoyed the video and see you next time. Bye bye.
Ya, begitulah ya. Penjelasan oleh Hannah Vogt-Jesusek ya, dari University of Graz, Austria. Ya. Hannah Vogt-Jesusek ini dengan tidak tahu suaminya apa saudaranya, Matthias Jesusek, mendirikan DataTab ya, yang analisa statistik softwarenya ya, yang juga dijelaskan tadi di videonya ya. University of Graz kalau di bidang teknik mesin sangat terkenal dengan simulasinya ya. Kita berikutnya akan mengikuti video apa yang dijelaskan oleh Hannah Jesusek, yaitu bahwa standar deviasi antara sampel dengan populasi berbeda ya tadi. Dan kenapa standar deviasi lebih disukai dibanding dengan varians? Ya, terutama satuannya yang make sense ya, lebih sesuai dengan yang diukur dibanding varian yang satuannya sama dengan kuadratnya tentu saja, dan ukurannya semakin lebar ya dibanding standar deviasi. Itu yang video oleh Hannah Vogt-Jesusek. Berikutnya kita akan mengikuti video dari Jeremy Blades-Jones ya. Ini dari Teacher College Columbia University ya. Yang animasinya bagus ya. Mudah-mudahan dengan animasi yang bagus memberi pengertian yang lebih baik kepada kita, dan standar deviasi dihubungkan dengan distribusi normal nantinya pada video oleh Jeremy Blades-Jones.
Have we discovered a new particle in physics? Is a manufacturing process out of control? What percentage of men are taller than LeBron James? How about taller than Yao Ming? All of these questions can be answered using the concept of standard deviation. For any set of data, the mean and standard deviation can be calculated. For example, 5 people may have the following amounts of money in their wallets: $21, $50, $62, $85, and $90. The mean is $61.60, and the standard deviation is $28.01. How much does the data vary from the average? Standard deviation is a measure of spread, that is, how spread out a set of data is. A low standard deviation tells us that the data is closely clustered around the mean, or average, while a high standard deviation indicates that the data is dispersed over a wider range of values. Standard deviation is used when the distribution of data is approximately normal, resembling a bell curve. Standard deviation is commonly used to understand whether a specific data point is standard and expected, or unusual and unexpected. Standard deviation is represented by the lowercase Greek letter sigma. A data point's distance from the mean can be measured by the number of standard deviations that it is above or below the mean. A data point that is beyond a certain number of standard deviations from the mean represents an outcome that is significantly above or below the average. This can be used to determine whether a result is statistically significant or part of expected variation. such as whether a bottle with an extra ounce of soda is to be expected or warrants further investigation into the production line. The 68-95-99.7 rule tells us that about 68% of the data fall within one standard deviation of the mean. About 95% of data fall within 2 standard deviations of the mean, and about 99.7% of data fall within 3 standard deviations of the mean. The average height of an American adult male is 5'10", with a standard deviation of 3 inches. Using the 68-95-99.7 rule, this means that 68% of American men are 5'10", plus or minus 3 inches. 95% of American men are 5'10", plus or minus 6 inches, and 99.7% of American men are 5'10", plus or minus 9 inches. So, this means only about 0.3% of American men deviate more than 9 inches from the average, with 0.15% taller than 6'7", and 0.15% shorter than 5'1". This reasoning suggests that LeBron James is 1 in 2,500 and Yao Ming is 1 in 450 million. In particle physics, scientists have what are called 5 sigma results that are 5 standard deviations above or below the mean. A result that varies this much can signify a discovery, as it has only a 1 in 3.5 million chance that it is due to random fluctuation. In summary, standard deviation is a measure of spread. Along with the mean, the standard deviation allows us to determine whether a value is statistically significant or part of expected variation. Thanks for watching. See you next time.
Created using Powtoon.
In this video, we're going to talk about how to calculate the standard deviation of group data. So here we have a class of students, and in a table on the left side, we have different classes of grades. 50 to 59, we'll say that's an F. 60 to 69 is a D. This is a C, and so forth. And to the right of that, we have a column that tells us the frequency of those values. So this means that 5 students had a score between 60 and 69, and 12 students had a score between 80 and 89. So with this information, where we're given the class ranges and the frequencies, how can we calculate the standard deviation of the scores that the students had, let's say, on an exam? How can we calculate the standard deviation given this information? The first thing we need to do is determine the midpoint of the class ranges. So what is the midpoint between 50 and 59? The lower boundary and the upper boundary of that first range. To find the midpoint, we basically need to average the two numbers. So we need to add them up and divide by 2. 109 divided by 2 is going to be 54.5. Now, if we average 60 and 69 for the second range, that's going to give us 64.5. And if we follow the pattern, we can see that the next one is going to be 74.5 and then 84.5. By the way, one thing I want to mention is that for this particular problem, the student scores that they received on an exam, we're going to say that all of those scores have been rounded to a whole number, because 69.5 is neither in this range or in that range. So we're going to say that all of the scores are whole number values or integer values. Now, we need to determine the midpoint between those two. It's not going to be 94.5. So we're going to add the lower boundary, which is 90, and the upper boundary, which is 100, divided by 2. So this is 190 divided by 2, and that turns out to be 95. So that's the first step. You want to calculate the midpoint of all of the ranges that you see here. Now the next thing we need to do is multiply the frequency column by the midpoint column. So this is going to be F times M. And let me give you the formula that we're going to use to calculate the standard deviation. The standard deviation is going to be the square root of the sum of the square of the deviations being the data values minus the mean, divided by n minus 1, where n is the number of data values in a list. Now, we're going to modify this equation for this particular type of problem. So whenever you're dealing with group data, you can calculate the sum of the square of the deviations by multiplying the frequency by the difference between the midpoint and the mean, and then you have to square those results, divided by n minus 1. So we're going to be using this formula in this video. So just keep that in mind. Now, before we calculate the standard deviation, we need to calculate the mean. The mean is basically the sum divided by the number of numbers in a list. For group data, the sum is going to be the frequency times the midpoint values, which is what we're going to get in the fourth column. And then we're going to divide that by the frequency values, which is what we're going to get here. So notice that these two are the same. The sum of the frequency values is equal to the number of data values in the list. So let's get rid of this. Now let's multiply the frequency by the midpoint. So first we have 3 times 54.5. And so that's going to be 163.5. Next, we're going to multiply those two. So 5 times 64.5. That's 322.5. And then 9 times 74.5. I got 670.5. And then just repeat the pattern. So for the last one, 8 times 95, that's going to be 760. Now, we don't need the sum of this column, but we do need the sum of the frequency column and the frequency times the midpoint values. So let's begin by adding up these numbers. So we have 3 plus 5 plus 9 plus 12 plus 8, and so that's going to give us 37. Let me just put a line right here. Now let's take the sum of these values as well. So I got a big number. I'm going to see if I can fit it here. It's 2930.5. So now we can calculate the mean. So it's going to be the sum of the frequency times the midpoint values divided by the frequency values. So it's 2930.5 divided by 37. And so that's about 79.2. Now, does this answer make sense? Do you think the mean is around 79? Well, notice that the bulk of the data is in this range. So 79 as the mean makes sense because most students, they scored between 70 and 89. So it makes sense that the mean is like around 79, 80. So now in the next column, we're going to put the mean, which is 79.2. And that's, of course, a rounded value. Now, for the next column, we're going to take the difference between the mean, not the mean, but the midpoint and the mean. X bar is the mean. So let's subtract 54.5 by 79.2. And so we're going to get negative 24.7. Now let's subtract these two numbers. So 64.5 minus 79.2. Now let's subtract these two. So that's going to be 74.5 minus 79.2, and so that's negative 4.7. And then we have 84.5 minus 79.2, and so that's positive 5.3. And then for the last one, 95 minus 79.2, that's going to be 15.8. Now we don't need to add up those values. For the next column, we're simply going to square the previous column. So basically, we're going to take negative 24.7 and square it. So it's going to turn into a positive value. It's going to be 610.09. 14.7 squared, that's going to be 216.09. And then 4.7 squared is 22.09. Next we have 5.3 squared. This is going to be 28.09. And for the last one, it's 249.64. Now the last thing we're going to do is we're going to multiply the frequency by the square of the deviations. So this is going to be f times m minus x bar squared. So it's going to be 3 times this number. And so that's going to be 1,830.27. Now let's multiply 5 by 216.09. And so you should get 1,080.45. Now this work is pretty tedious, but this is how you would do it if you're not going to use Excel or a calculator. For the next one, we have 12 times 28.09. And so that's going to be 337.08. And for the last one, it's 8 times 249.64. And so that's 1997.12. Now, we do need to take the sum of that column. So let's add those 5 numbers. And so you should get 5,443.73. Now that we have the sum of the frequency times the deviation squared, we can calculate the standard deviation using this formula. So it's going to be the sum of the frequency times the square of the deviations, divided by n minus 1. So this number represents everything that you see here. So we're going to replace this term with 5,443.73. N is this number, 37. So we have n minus 1, or 37 minus 1. So it's going to be 5,443.73 divided by 36, because that's 37 minus 1. And so that's going to give you 151.2147 with some extra numbers. And then when we take the square root of that result, our rounded answer, so it's going to be approximately 12.3. So that's the standard deviation for this grouped frequency data. And that's how you could find it for this type of problem. Thanks for watching.
Kita telah menyaksikan ya video yang kelima, yaitu kembali oleh Julio Gonzalez ya, yang memberi contoh bagaimana menghitung standar deviasi dari data yang dikelompokkan atau grup data ya. Kemudian nanti kita akan mengikuti video yang terakhir ya dari standar deviasi ya, yaitu dari 365 data science ya. Ini lagi-lagi adalah blog tentang pengetahuan, tapi ini di Bulgaria ya, tidak di AS seperti Julio Gonzalez. Yang menarik dari video ke-6 adalah didiskusikan coefficient of variation ya. Misalnya dicontohkan tadi adalah harga pizza yang dalam dolar, kemudian misalnya harga pizza dalam rupiah ya misalnya. Dengan data yang sama, ya tentu saja karena nilai mata uang yang berbeda, ya, maka standar deviasinya berbeda ya, padahal datanya sama ya. Kalau di video nanti contohnya dalam peso ya. Agar mudah membayangkan ya seandainya dalam rupiah ya. Data yang sama kalau kita nilai dalam dolar harganya, kemudian data yang sama ya, dalam rupiah ya karena dikonversikan nilai tukarnya, maka kalau standar deviasi akan menghasilkan nilai yang berbeda, padahal berasal dari data yang sama ya. Hanya karena faktor konversi mata uang. Seharusnya ya, karena berasal dari data yang sama, maka seharusnya ukuran persebaran dari nilai rata-ratanya harusnya sama ya kan. Nggak tahu itu uangnya dalam rupiah atau uangnya dalam peso atau uangnya dalam dolar. Oleh karena itu diperkenalkan ya, variabel baru yang namanya coefficient of variance ya, yaitu dengan membagi standar deviasi dengan nilai rata-ratanya.
There are many ways to quantify variability. However, we will focus on the most common ones: variance, standard deviation, and coefficient of variation. In the field of statistics, we will typically use different formulas when working with population data and sample data. Let's think about this for a bit. When you have the whole population, each data point is known, so you are 100% sure of the measures you are calculating. When you take a sample of this population and you compute a sample statistic, it is interpreted as an approximation of the population parameter. Moreover, if you extract 10 different samples from the same population, you will get 10 different measures. Statisticians have solved the problem by adjusting the algebraic formulas for many statistics to reflect this issue. Therefore, we will explore both population and sample formulas, as they are both used. You must be asking yourself why there are unique formulas for the mean, median, and mode. Well, actually, the sample mean is the average of the sample data points, while the population mean is the average of the population data points. So technically, there are two different formulas, but they are computed in the same way. Okay, now, after this short clarification, it's time to get on to variance. Variance measures the dispersion of a set of data points around their mean value. Population variance, denoted by sigma squared, is equal to the sum of squared differences between the observed values and the population mean divided by the total number of observations. Sample variance, on the other hand, is denoted by S squared and is equal to the sum of squared differences between observed sample values and the sample mean divided by the number of sample observations minus 1. Alright, when you are getting acquainted with statistics, it is hard to grasp everything right away. Therefore, let's stop for a second to examine the formula for the population and try to clarify its meaning. The main part of the formula is its numerator, so that's what we want to comprehend. The sum of differences between the observations and the mean, squared. So, the closer a number to the mean, the lower the result we will obtain, right? And the further away from the mean it lies, the larger this difference. Easy. But why do we elevate to the second degree? Squaring the differences has two main purposes. First, by squaring the numbers, we always get non-negative computations. Without going too deep into the mathematics of it, it is intuitive that dispersion cannot be negative. Dispersion is about distance, and distance cannot be negative. If, on the other hand, we calculate the difference and do not elevate to the second degree, we would obtain both positive and negative values that when summed would cancel out, leaving us with no information about the dispersion. Second, squaring amplifies the effect of large differences. For example, if the mean is 0 and you have an observation of 100, the squared spread is 10,000. Alright, enough dry theory. It is time for a practical example. We have a population of 5 observations, 1, 2, 3, 4, and 5. Let's find its variance. We start by calculating the mean. 1 plus 2 plus 3 plus 4 plus 5 divided by 5 equals 3. Then we apply the formula we just saw. 1 minus 3 squared plus 2 minus 3 squared plus 3 minus 3 squared plus 4 minus 3 squared plus 5 minus 3 squared. All of these components have to be divided by 5. When we do the math, we get 2. So, the population variance of the dataset is 2. But what about the sample variance? This would only be suitable if we were told that these 5 observations were a sample drawn from a population. So, let's imagine that's the case. The sample mean is once again 3. The numerator is the same, but the denominator is going to be 4 instead of 5, giving us a sample variance of 2.5. To conclude the variance topic, we should interpret the result. Why is the sample variance bigger than the population variance? In the first case, we knew the population. That is, we had all the data and we calculated the variance. In the second case, we were told that 1, 2, 3, 4, and 5 was a sample, drawn from a bigger population. Imagine the population of this sample were these 9 numbers: 1, 1, 1, 2, 3, 4, 5, 5, 5, and 5. Clearly, the numbers are the same, but there is a concentration around the two extremes of the dataset, 1 and 5. The variance of this population is 2.96. So, our sample variance has rightfully corrected upwards in order to reflect the higher potential variability. This is the reason why there are different formulas for sample and population data. While variance is a common measure of data dispersion, in most cases the figure you will obtain is pretty large and hard to compare, as the unit of measurement is squared. The easy fix is to calculate its square root and obtain a statistic known as standard deviation. In most analyses you perform, standard deviation will be much more meaningful than variance. As we saw, there are different measures for the population and sample variance. Consequently, there is also population and sample standard deviation. The formulas are the square root of the population variance and square root of the sample variance, respectively. I believe there is no need for an example of the calculation, right? If you have a calculator in your hands, you'll be able to do the job. Alright, the other measure we still have to introduce is the coefficient of variation. It is equal to the standard deviation divided by the mean. Another name for the term is relative standard deviation. This is an easy way to remember its formula. It is simply the standard deviation relative to the mean. As you probably guessed, there is a population and sample formula once again. So, standard deviation is the most common measure of variability for a single dataset. But why do we need yet another measure such as the coefficient of variation? Well, comparing the standard deviations of two different datasets is meaningless, but comparing coefficients of variation is not. Aristotle once said, "Tell me, I'll forget. Show me, I'll remember. Involve me, I'll understand." To make sure you remember, here's an example of a comparison between standard deviations. Let's take the prices of pizza at 10 different places in New York. They range from $1 to $11. Now, imagine that you only have Mexican pesos, and to you, the prices look more like 18.81 pesos to 206.91 pesos, given the exchange rate of 18.81 pesos for $1. Let's combine our knowledge so far and find the standard deviations and coefficients of variation of these two datasets. First, we have to see if this is a sample or a population. Are there only 11 restaurants in New York? Of course not. This is obviously a sample drawn from all the restaurants in the city. Then we have to use the formulas for sample measures of variability. Second, we have to find the mean. The mean in dollars is equal to 5.5 and the mean in pesos to 103.46. The third step of the process is finding the sample variance. Following the formula that we showed earlier, we can obtain $10.72 squared and 3,793.69 pesos squared. The respective sample standard deviations are $3.27 and 61.59 pesos. Let's make a couple of observations. First, variance gives results in squared units, while standard deviation in original units. This is the main reason why professionals prefer to use standard deviation as the main measure of variability. It is directly interpretable. Squared dollars means nothing, even in the field of statistics. Second, we got standard deviations of 3.27 and 61.59 for the same pizza at the same 11 restaurants in New York City. Seems wrong, right? Don't worry. It is time to use our last tool, the coefficient of variation. Dividing the standard deviations by the respective means, we get the two coefficients of variation. The result is the same, 0.60. Notice that it is not dollars, pesos, dollars squared, or pesos squared. It is just 0.60. This shows us the great advantage that the coefficient of variation gives us. Now, we can confidently say that the two datasets have the same variability, which is what we expected beforehand. Let's recap what we have learned so far. There are three main measures of variability: variance, standard deviation, and coefficient of variation. Each of them has different strengths and applications. You should feel confident using all of them as we are getting closer to more complex statistical topics. Thanks for watching.
Demikianlah ya karakteristik data ya dari populasi dan sampel ya. Yang pertama adalah mean atau rata-rata, kemudian variance, kemudian standar deviasi, dan coefficient of variation ya yang terakhir, dengan berbagai video ya yang diambil dari channelnya Julio Gonzalez, terus kemudian kuliah dari Profesor Daniel Sturridge ya dari Denver, Colorado, maupun dari Hannah Fox Jesusek ya dari Uni of Grace dengan data lab-nya, dan juga kuliah oleh Jeremy Blitz Jones ya dari Teacher College Columbia ya. Kemudian juga ada channel dari 365 Data Science ya dari Bulgaria. Saya rasa mahasiswa harusnya sudah sampai pada pengertian yang mendalam tentang rata-rata, varian, standar deviasi dari sampel yang seharusnya menggambarkan data dari populasinya ya.